What is quantum entanglement? Hello and welcome back to our channel, where we bring you all the fascinating and thought-provoking aspects of science. Today, we'll be discussing one of the most perplexing concepts in the world of physics, quantum entanglement. It's a bizarre phenomenon that has puzzled scientists and intrigued the masses since the discovery of quantum mechanics in the early 20th century. What is quantum entanglement? Quantum entanglement is the phenomenon where particles, such as electrons, photons, or atoms, become correlated in such a way that they're bound, or entangled, to each other, regardless of the distance between them. This strange phenomenon occurs due to the principle of quantum superposition, which states that a particle can be in two states, or positions, at once, until it's measured or observed. That's when the state of the particle becomes fixed, but the act of measurement also affects the state of the entangled particle. The concept of quantum entanglement was first introduced by Albert Einstein, Boris Podolsky, and Nathan Rosen in their 1935 paper, known as the EPR paradox. In this paper, they describe how particles can be linked together in such a way that any change to one particle's property will cause a corresponding change to the other particle, even if they're separated by vast distances. Einstein famously called this phenomenon spookyation at a distance. In the 1960s, physicist John Bell proposed a test to prove whether or not quantum entanglement was a real phenomenon. Bell's inequalities suggested that if there were local, hidden variables that were influencing the properties of the entangled particles, then there would be a limit to the correlations between them. However, experimental tests later confirmed that Bell's inequalities were violated, proving that quantum entanglement was real. Applications of quantum entanglement. Quantum entanglement is not only a fascinating phenomenon, but it also has practical applications. One such application is quantum cryptography, where the entangled particles are used to send encrypted messages. Since the particles are correlated, any unauthorized attempt to measure them will be immediately noticed, and the message will be destroyed. Quantum entanglement is also being studied for its potential use in the development of quantum computers. Quantum computers operate based on the principles of superposition and entanglement, which would allow for much faster computational speeds and the ability to solve complex problems that classical computers cannot. The future of quantum entanglement. Quantum entanglement is still not fully understood, and research is ongoing to discover more about this phenomenon. One area that researchers are exploring is the use of quantum entanglement in teleportation, not in the Star Trek sense of beaming someone from one place to another, but in the sense of transferring information from one particle to another without physically moving it. In conclusion, quantum entanglement is a strange, but very real phenomenon that has captured the attention of physicists, researchers, and the general public for many years. Its practical applications and potential for future advancements in scientific research make it an area of great interest. It is still being studied, and there is much to be uncovered about this intriguing concept. Thank you for joining, and we look forward to bringing you more fascinating science in the future. Thanks for watching.